A client wanted a reproduction of this newel post, wanted actually 1.5 newel posts reproduced so that both of them would be on a landing, but one would be against the wall, so that would be a half newel. So this is going to be painted, and it was high traffic area, so it was decided to be made out of hard maple paint grade. Here I am turning one of the newels and just kind of working on the column area. I decided to make these newels in different sections because I decided it would be easier to make parts fit together, and it would also be a little less dangerous instead of making this all out of one huge piece of hard maple. Truing up the square corner of a hard piece of maple, it's kind of tricky, so you have to be pretty careful with the tool, but it turned out well here. I bored a hole in the end of the column area, and I used a succession of gradually larger and larger Forstner bits instead of trying to take one big bite with just the final size Forstner bit. And here's another angle of the same thing. I came in initially with a turning tool, just turning a recess that's the size of the final size bore. That way, when I do the final bore, the bit has a place to land, otherwise it'll just not be sure where to cut. Here I'm turning the pin end of the block area and just making sure that it's just a little undersized from the size of the bore, because I'm going to be epoxying this in, and when I epoxy things in like this, I prefer things to be just a little bit on the loose side. Turning one of the finials, and I set the old finial in the back there so I can have a good visual to see what I'm copying correctly. I use a Conover lathe that I really love. I bought it about 30 years ago, and turning the open end of the top of the finial. I'm using an independent 4-jaw chuck on the lathe here, which grabs the finial very nicely. In this situation, I glued up the finial blank with a piece of newspaper in between the two halves. That way it would allow me to split the finial in half. And I'm using a very dull chisel here. This is about as sharp as a butter knife. I made a jig that would allow me to route a round recess for the what I'm calling the flower detail. Have my dust collector hose there to take the bulk of the chips. And I had my CNC carving these petal areas that's what I'm calling it, but it didn't do so well, so I ended up having to do a lot of handwork, and carving maple is not so easy, but it worked out. And here I'm just cutting off the petal area from the rough turning area. I put a little scrap of wood in the 4-jaw chuck and created a tapered area that I could grab the petal detail with and just turn off the bulk of the wasted material. The rest of the little bit that's left there, I ended up using a grinder just to grind that off. And I have a slightly concave face on that back end so that the outer edge will mate nicely with the square end of the newel post. And I didn't show in the video, but I turned the little finial that with a pin that would capture the petal detail, and then that would all be epoxied into the bottom end of the newel post. Here I'm routing a chamfer in the round recess area. I had to really look all over the internet to try to find a chamfering bit that would have a bearing that would fit in that shallow space, and I ended up finding something that's more for a Dremel tool. It's an 1/8" shank fixed bearing chamfering bit, and I had to actually grind off a bit of the bearing end so that it would be able to fit in that space, and it just worked out. I turned the newel posts on their heads basically and epoxied the pedal detail to the tops of the blocks, and then after that, I don't show it here, but I epoxied in the little finial ends, so everything's locked in. I cut one of the newels in half, the one that's going to go against the wall, and I just cleaned it up on the joiner. And here it is. Everything's epoxied together, and I use marine grade West system, and that works out really nicely. SketchUp is a great 3D modeling software program. It's a lot of fun once you kind of get the hang of how things work. It's kind of nice to see it in this video sped up, because when I'm using it, typically I'm kind of trying to figure out what tools and what maneuvers I need to do to get to the end result. This model that I'm creating will be turned into an STL file, which I then send to another program called VCarve Pro, Aspire, and that program allows this model to be converted into language called G-code, which my CNC machine will then be able to read and be able to carve. And here we see the carving happening. I didn't show the first phase of this carving, which is more of a hogging out thing. I use a larger bit just to waste away most of the material that won't be needed. And this bit here, it's a 16th round nose tapered ball end bit, and I still had to do some hand sanding to sand out the machine marks. Boring a hole in the center to receive the little button detail that you'll see next. I'm on the lathe here turning the little button detail. Gluing in the little button is kind of neat. And now is the moment of truth. I'm gluing and pin nailing the flower detail into the recess and making sure it's square in the same orientation as the original. I'd hate to pin that in and find out I had it at the wrong angle. I use a 23 gauge pin nailer here, and that works really nicely. And here's a view of the finished product. I ended up using a Japanese pull saw to cut off the half of the flower detail on the half newel that wasn't needed. And the job is finally done. I provided the newel posts and other parts to the company that installed everything. I was just a supplier. But I'm happy with everything. So thanks for taking a look at this video. I appreciate your watching it.